We have the first question here on geometric progression, sequence and series. The second and fifth terms of a geometric progression are 5 and 5/8 respectively. Find the common ratio. First term, sum of the first and second terms. So recall that for a geometric progression is of the form A first term, AR second term, AR squared third term, AR exponent 4, AR exponent 3 fourth term, AR exponent 5, AR exponent 4 fifth term, and so on and so forth. So the question is saying that this term here, which is the second term, is equal to 5, and the fifth term, 1, 2, 3, 4, 5, the fifth term is equal to 5/8. So we are to find the common ratio, which is R, and then we'll find the value of A. So we can form simultaneous equations here and solve. AR is equal to 5. So this one. Equation 1. Then we have this one too, another equation. AR exponent 4 is equal to 5/8. Another equation here, equation 2. We have to solve these two equations for the value of A and R. So we can divide equation 2 by equation 1 so that the A's will cancel and the R's will reduce. If you add, it will not cancel out. If you subtract, it will not cancel out. If you multiply, it will not cancel out. So you have to divide. So AR exponent 4 divided by AR. So in other words, we are doing equation 2 divided by equation 1. So 5/8 divided by 8. So let's simplify that. So A will cancel A, then the R here is like R exponent 1. So you use indices. So you pick one base, R, then you subtract the exponent. 4 minus 1 is equal to, now when you come here, you can also write it as 5/8 divided by 8. Divided by 5. This is 5, not 8. So divided by 5. So this will give you R exponent 3 is equal to 5/8 times 1/5. So the 5 will get rid of the 5. We have R exponent 3 is equal to 1/8. So R will be equal to the cubic root of 1/8. So you can use your calculator here and you see that the value of R is 1/2. So the common ratio is 1/2. The first term. So to find the first term, we can put R equal 1/2 in equation 1. So let's do that. So recall that equation 1 is AR is equal to 5, and we had R to be equal to 1/2. So A times 1/2 is equal to 5. So it times both sides by 2. A will be equal to 5 times 2. That will give us 10. So the first term is 10. So 10 half Then we have to find the sum of the first and second terms. So the first term, so this is B. The first one was A. So the sum of the first and second terms. The first term is A, the second term is AR. So A is 10. Then AR. A is again 10 and R is 1 over 2. So that will give us 10 plus 5 and that will give us 15. We have the second question here. The second question is on percentages and also simple interest. 80 boys and 70 girls take an examination. 15% of the boys and 10% of the girls fail. What percentage of the whole number failed? Find the amount of Ghana cedis 350 in 6 years at 4% simple interest. So let's begin with the A part. "80 boys." So we want to find the number of boys who failed. So number of boys who failed. Number of boys who failed will be equal to 15%. That is 15 over 100 times 80. Then we can simplify this to get, we know 5 can go into 15 3 times, and 5 can go into 100 how many times? 20 times. 20 can go into 80 how many times? 4 times. So 3 times 4 will be 12. So the number of boys who failed are 12. Then similarly, number of girls who failed will be equal to 10%. That is 10 over 100 times 70. So this will simplify to, we know 10 will go into 100 10 times, and 10 will go into 70 7 times. So 7 girls failed. Now to find the percentage of the whole number that failed, we must first of all calculate the total number that failed. So total number who failed, total number of students who failed will be equal to 12 boys and 7 girls, which is equal to 19 students who failed. So now, percentage of students who failed. Percentage of whole number who failed. One fifty, which is 100%. So we can simplify this, and this will give us 12 whole number. I want to leave that out to you. 12 whole number 2 over 3%. So I want you to simplify it and get 12 whole number 2 over 3%. Now let's look at the B part of the question. We have to find the amount of. So from the question, we know the principal to be 350 Ghana cedis. So 350 Ghana cedis. 350 Ghana cedis. We add it to the interest, which is 350 Ghana cedis. So let me do everything in Ghana cedis. 350 times the time is 6 years times the rate, which is 4%. So this will give us 350 all in Ghana cedis. 350. Adding it to, when we simplify this, we are supposed to get, 4 will go into 100 how many times? 25 times. Then 350 will divide, 5 will go into, okay, 50 will go here. Okay, let me do it like this. 2 will go into 4. 2 will go into 4 2 times. And 2 will go into 100 50 times. Now 50 will go into 350 7 times. So we have 7 times 6 times 2. That will give us 6 to 12. Then 12 plus 12 times 7 will give us 84 cedis. So 84 adding to 350 will give us Ghana cedis 434. Alright. We have the third question here on mensuration. The angle of a sector of a circle with radius 22 centimeters is 60 degrees. If the sector is folded such that the straight edges coincide, forming a cone, calculate correct to 1 decimal place the radius, the height, the volume of the cone. So let's begin finding the radius. So radius of the cone R is given by the formula theta over 360 degrees. So remember this formula, please, times big R. So big R here is standing for the radius of the sector, and this small r here is standing for the base radius of the cone. So this is what we are talking about. So this is small r and this is big R, because the sector has been folded to form, this is the sector that is folded to form the cone. So the radius here, which is the radius of the sector, will be equal to the slant height of the cone, which is equal to 22 centimeters. So theta is giving us 60 degrees. So R is the base radius of the cone, will be equal to 60 degrees over 360 degrees times 22 centimeters. And this will be equal to 1 over 3, because 60 will go into itself 1. It will go into 360 how many times? It will go into 360 6 times. Then 2 will go into this 11 and 2 will go into this 3. So we get 1 over 3 times 11 centimeters. And when we simplify this, we will get 3.7 or 3.666 recurring, and we will run that to, this will run to 3.7 centimeters, because we are asked to run to one decimal place. Then the B part says we should find the height of the cone. So the height of the cone is here. This is a right angle triangle, and we know the radius is here. So we can see that r squared, h squared plus the base radius squared will be equal to big R squared. So we substitute the values. So we get h squared plus r squared, which is 11 over 3. 11 over 3. I'm going to use the 11 over 3. I will not use the approximated value. 11 over 3 squared. 11 over 3 squared. Sometimes if you use the approximated value, it affects your final results. It will be inflated or deflated more than necessary. So h squared plus 11 over 3 squared is equal to 22 squared. So we need to solve for h. So we are going to get h squared to be equal to 484 minus 121 over 9. Because 11 squared over 3 squared will give you 121. And 22 squared will give you 484. So you subtract that from 484. And that will give you h squared to be equal to 4235 all over 9. All over 9. So we take square root of that. So h will be equal to square root of 4235 over 9, which will give us 11 root 35 over 3. And this will simplify to 21.7 centimeters. Now let's find the volume of the cone. So we know that volume of cone is given by 1 over 3 pi r square h. So that will give us 1 over 3 times pi, which is giving us 22 over 7, times 11 over 3 squared, the radius we found, times 11 root 35 over 3. So that was the value we found for h, and this was the value we found for r. So let's simplify this. This will give us 1 over 3 times 22 over 7 times 121 over 9, and times 11 root 35 over 3. So let's simplify this further, and this will give us the volume to be equal to 29,282 square root of 35 all over 567. So 29,285 root 35 over 567. So this will simplify to 305.53 centimeter cube. To one decimal place, that will give us 305.5 centimeter cube. Now let's look at this question. Question number 4 is on trigonometry and change of subject. The A part says we should solve tan theta minus 45 degrees is equal to root 3 over 3. So please don't use the tan to expand. No, don't do that. So the tan is a function. So what you're going to do is that just consider all these things here as one angle, let's say A. Then you take tan inverse of both sides. So the question is tan theta minus 45 degrees is equal to root 3 over 3. So you take tan inverse of both sides. That will give you theta minus 45 degrees, or that whole angle A is equal to tan inverse of root 3 over 3. And tan inverse of root 3 over 3 will give us tan inverse of root 3 over 3 will give us 30. So theta will be equal to 30 degrees. Then so theta minus 45 will be equal to 30 degrees. Then you group like terms to get 30 degrees plus 45 degrees. So I didn't write that one, but you can write it before getting here. So you can see that theta will be equal to 75 degrees. Now let's look at the BI part. The BI says that we should use the relation y equal x minus 1 over square root of t minus v squared to calculate correct one decimal the value y, given that x equal 50, t equal 2.5, and v equal 0.6. So we fix in the values and start the calculation. So is y is equal to x minus 1 of t minus v squared. So we are going to put x equal 50, then we put t equal 2.5, then we put v equal 0.6. So that will give us y to be equal to x, which is 50, minus 1 all over square root of 2.5 minus 0.6 squared. So this will give us y to be equal to 49 minus square root of 2.5 minus 0.36. So this will give us y to be equal to 49 over square root of 2.14. And this is going to give us 49 over 1.46287. So this will simplify to 33.4958, and to one decimal place you get 33.5. So now let's consider the I part. So this is BI, the I part. So the I part says that we should make T the subject of the relation in B above. So the equation is y is equal to x minus 1 all over square root of t minus v squared. And we are asked to make t the subject. So what we are going to do is to first of all multiply both sides by square root of t minus v squared. Square root of t minus v squared. So multiply both sides by that. Or let's cross multiply. So 1 will times x minus 1 to get x minus 1. Then y will times square root of t minus v squared. Note that the square on the v cannot cancel the square root because it is not t minus v all squared. So you can't do that. Now let's divide through by y. So we get x minus 1 over y is equal to square root of t minus v squared. So this time we can square both sides to get this and this. So this is the square that can cancel the square root. Now we're going to share the square for x minus 1 and y. So that will give us x minus 1 all squared over y squared is equal to t minus v squared. So we can send the v squared to this expression here. So we are going to get x minus 1 all squared over y squared plus v squared will be equal to t. All t is equal to that. T is equal to v squared plus x minus 1 all squared all over y squared. This is okay. We can leave it like this. So let's move on to question number 5. Question 5 is on circle theorem. 5a is on circle theorem. So we have to calculate in a diagram. O is the center of the circle. A and C are points on the circumference of the circle. BCO is a straight line. BA is a tangent to the circle. AB is equal to 8 centimeters and OA is equal to 6 centimeters. We have to calculate the length of BC. So this is a tangent and this is a radius. And we know that the tangent and the radius, they meet at 90 degrees. So if that is the case, it means that triangle BOA is a right angled triangle. Therefore, BO squared, which is the hypotenuse, will be equal to AO squared plus AB squared. So if that is the case, we know that BO squared will be equal to AO, which is 6 centimeters squared, plus AB, which is 8 centimeters squared. So this will be equal to 36 plus 64. So BO squared will be equal to 100. So BO will be equal to square root of 100, which is 10 centimeters. Then we know that BO is made up of BC and CO. So we have BC plus BO, BC plus OC being equal to BO. So this is what will give us the 10. So I'm using this to represent BO. So BC, what we are looking for, plus OC. OC is the radius, which is 6 centimeters. So plus 6 is equal to 10. So BC, magnitude of BC will be equal to 10 minus 6, which is equal to 4 centimeters. So the length of BC is 4 centimeters. Now let's look at question 5b. A number is chosen at random from the set of integers 10 to 31 inclusive. Find the probability that the number is a multiple of 3 or 4. So the sample space will be S equal 10. Number is chosen from 10 to 31. 10 11, 12, 13, up to 30. So that's the sample space. Now the number of elements in this sample space will be 31, not 30. If it is from 11 to 30, that will give us 30. But from 10 to 30, we have 21, 21, sorry, 21 elements there. So we were told that we have to find the probability that the number is a multiple of 3 or 4. So let event A be multiples of 3. So event A will have elements 3, 6, 9, 12, 15, 18, 21, 24, 27, and 30. Event B will be the multiples of 4. Multiples of 4 are 4, 8, 12, 16, 20, 24, then we have 28. So event A intersection B is not a null set. So that will be mutually inclusive. So the event is not mutually exclusive. So intersection B will be 12, 12 here, 12 here. Then we have 24 here, 24 here. So probability of A or B will be equal to probability of A plus probability of B minus probability of A intersection n of A over n of S, which is 10 over 21. So show that one, n of A over n of S, n of A, n of B over n of S, n of A intersection B over n of S. You can show that one before coming here. So plus we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's what gives us the 10. Then for B, 1, 2, 3, 4, 5, 6, 7. So 7 over 21. Then we subtract the intersection, which is 2. 2 over 21. And this will simplify to 5 over okay, let's go step by step. It will give you 15 over 21. 15 over 21. And it will still simplify to 3 will go into 15, 5, and 3 will go into 21, 7. Thank you for connecting with us live to go through all this. We'll continue in the next live stream.